This video is created to demonstrate normal mapping and different shading techniques as a part of my third assignment for CS7GV3 real-time rendering. Here I have three different models: the Utah teapot, Suzanne the monkey from Blender, and a rounded cube. I will be using them with multiple texture sets and two different cube maps as environment skyboxes. These are three different shading modes to display different lighting: blend fong shading, toon shading, and cook torrents. All of them support normal mapping, and I also created custom hand-painted normal maps for each model. Normal mapping is a technique that adds surface detail to 3D models without adding extra geometry. Instead of modeling every bump and crack, which can have a really high polygon count, we store that detail in a texture called a normal map. The normal map encodes the direction each point on the surface should face. These directions are stored as RGB colors, where red, green, and blue represent different spatial directions. When the shader processes each pixel, it reads the normal map and uses those directions to calculate how light should interact with the surface of the object. This creates the illusion of complex bumps, scratches, and surface features, even though the actual geometry is smooth and relatively has a lower polygon count. You can see this clearly when I toggle the map on and off over here. I have 5 different texture options in the UI. The first option uses no textures, just flat shading with pure geometry. The next 3 options are physically based rendering texture sets from Polyhaven, aerial rocks, damaged plaster, and rusty metal grate. Each of these comes with a color texture, which is an albedo or a diffuse texture, and a normal map that adds surface detail and gives it an appearance that is more complex and higher polygon. The fifth option is where I used my custom hand-painted normal maps, which I created by baking the normal maps of each single model in Blender and then painting over them in Procreate before plugging them into OpenGL.